In this tutorial, we will be discussing the use of energy equations to solve energy problems. The first equation we're going to look at is the equation for gravitational potential energy. The equation used to determine gravitational potential energy is Eg is equal to mgh. To use this equation, we need to remember that m is referring to the mass, g is referring to the gravitational acceleration. It's important to understand that that's the gravitational acceleration and not the force of gravity, which is the weight of the object. Remember, gravitational acceleration on Earth is approximately 9.8 meters per second per second. And finally, h refers to the height of the object above the surface. Since we have more than 3 variables, our traditional circle will not work. However, what we can do is we can use a circle for our equations that looks like this. And since mass is multiplied by gravity and multiplied by height, we would put those in the bottom, and our Eg would go in the top. So we could use this type of circle to solve these equations. Remember that these on the bottom would be multiplied by each other, and then anything on the top would be divided by whatever on the bottom. So we can manipulate any of these variables to find the fourth one. The kinetic energy equation is a bit more complex. To solve for kinetic energy, we take 1/2 or 0.5 multiplied by the mass multiplied by the velocity squared. That's 1/2 mv squared. So again, m is equal to the mass and v is equal to the velocity. Manipulating this equation becomes a bit more difficult simply because the velocity is squared. So if you are solving a problem for velocity, where you're trying to find the velocity of the object, you will take 2 multiplied by the kinetic energy divided by the mass, but then you need to remember that you have to take the square root of that, because in the equation above, the velocity is squared. So you need the square root of 2ek divided by m. Now let's work on some practice problems with these equations. A 1,500 kilogram car uses 300 joules of energy to accelerate. Determine its final velocity. You can assume that it had a starting velocity of 0. And one thing to note, energy is measured in joules. Okay, that is the unit of measurement for energy. Pause the recording and determine the velocity. Answer this problem, please. In this problem, the mass is equal to 1,500 kilograms and the kinetic energy is 300,000 joules. We do not know the final velocity. So remember, if you are solving for velocity, you're going to take the square root of 2 times the kinetic energy divided by the mass. When you plug in the numbers, you get v equals the square root of 400, which means v equals 20. And since we're talking about velocity, that should be measured in meters per second. Hopefully you got the right solution. Let's go on to the next problem. Problem number 2, if the kinetic energy of an object is 10 joules, when it has a velocity of 3 meters per second, what is its mass? Again, pause the video and solve the problem. When we manipulate the formula to solve for m, or mass, we get m equals 2ek divided by v squared. When we plug in the numbers and solve, remembering to square the velocity, we get 20 divided by 9, which is 2.2 kilograms, because we are solving for mass. The gravitational potential energy formula is Eg is equal to mgh. Since we know the m and the g and the h, we can easily solve this problem. Plug in for the 2 kilograms multiplied by 9.8 or 10 newtons per kilogram on the Earth times the height, 2 meters. We get an answer of 40, and remember, joules, because it's a measurement of energy. If you're curious about how we get joules from these units, let's talk about that briefly. In the previous problem, we had these units, kilograms times newtons per kilogram times meters. Remember that a newton is equal to a kilogram times a meter per second squared. That's over kilograms. And then that's, again, times meters. So we just substituted in for the newtons here. Now we can start canceling things out. A kilogram over a kilogram is going to cancel. Meters times meters is going to give you meters squared. So really, a joule is a kilogram times a meters squared over seconds squared. But just like the Newton, we don't want to have to write that out all of the time. And so instead, we just label it with a joule. Okay, for the final practice problem, the question is, how much gravitational energy does a 60 kilogram person gain if they jump 0.25 meters upwards? You can assume that we are on the Earth. Please make sure that you pause the video and solve the problem. We are going to use the formula Eg equals mgh. Substitute in everything that you know from the problem and then do the math. You will get gravitational potential energy is equal to 150 joules. And that's it for this tutorial. Thanks for learning with me. Have a great day.